RISACalc is a web-based application for individual component design, which provides engineers with an easy-to-use interface that allows for full control over inputs such as geometry and loading, in addition to graphical and numerical results, including robust detailed reports. In this video, we'll take a look at the stainless steel member design functionality in RISACalc. So in this case, we're going to start with a beam here. I'm going to go to properties real quick, and we have our stainless steel material already set. I can go ahead and choose a shape type. So let's go ahead and choose maybe this rectangular tube. The shape database will change, and then I can go ahead and pick a specific shape. So let's just go ahead and pick one here from the list. So maybe a, 12 by 12 by 5. We can also then choose our material or create a custom one. And then we can go ahead and look at the properties of that material as well to see our material properties. Before leaving the properties, we can go ahead and open up the gear here to see our stainless steel codes that are available. So both AISC codes. Next, with the basic information or basic properties of the beam defined, I'm going to go ahead and click on span. So we could add additional spans or we could add additional boundary conditions. In this particular case, I'm just going to go ahead and change this roller condition to a fixed condition. So we have a pin and a fixed condition. Next, I can go ahead and click design. And these conditions are very similar to what we have for steel. And so we can go ahead and change the bracing or the bracing locations for this particular stainless steel member. And so let's go ahead and brace it out of plane at the supports. And then I'm going to go ahead and brace the top flange at the supports as well. Now I can go ahead and make some changes to the K factor, the CB factor, but let's just go ahead and add some loads. So under loads, we have two options, point loads and distributed loads. I'm going to first go ahead and add in a point load. So I'm just going to add a point load, be it a live load with a certain magnitude. Let's make it 1 kip and apply that at the 5-foot location. And I can go ahead and turn on my load so we can see those. And then if I go ahead and select one of this load here, I can actually see the dimensions and go ahead and make a change to that. So maybe I want to change this magnitude to 1.5 kips. Now, additionally, I can go ahead and add in distributed loads. So if I click distributed load, maybe we want to add in a variable distributed load. So maybe in the dead load case, we can say a distributed load from 0.35 to 0.6 kips per linear foot. So we've got that linearly increasing distributed load. We can also set the location. In this case, we'll keep it to the entirety of the beam. Now, all the while, as we've been creating live loads and dead loads, we've already had our combinations created for us. We could even modify the way the combinations are created, including what combinations we're going to use. But in this case, we're just going to stick with what we have here. And when we're ready to run the analysis, we can go ahead and click the check mark to toggle on the unity check. Now, when the unity check is complete, I'm going to go ahead and minimize the detail report. And we can see some of the values or some of the result information that's already available to us. In this case, we have the reactions toggled on and the deflections already toggled on. We could toggle those both off and maybe turn on our moment diagram as well as our shear diagram. We can see on the diagrams that we have different information as we kind of move through the diagram itself. So we can look at different locations and see that value there. We could also go ahead and see the governing load combination and code check that are being used here. Now, in addition to these graphical results, we can also expand the detailed report, look at some of similar results, so property information, our load combination information, but more importantly, we can go to the calculations tab and we can see all the detail for the calculations. So if we go to look, for instance, at our flexural analysis, we can see every step of the flexural analysis, from checking of the slenderness ratio to defining of yielding and flange local buckling, all the way down to getting our allowable flexural strength about the strong axis here. And with this, we can see the code provisions that are used for this particular case. Now, if we're ready, we can go ahead and also download the PDF for viewing later. Let's go ahead now and create a second member. So I'm going to create a stainless steel column. So I'm just going to hit the plus key here, and we'll create for us a column. Now I'm going to go back up to properties. I'm going to change my material to stainless steel, and then we can set a different shape. So maybe in this case, we want to keep it as a wide flange. And so we can go ahead and choose a wide flange shape. So maybe a 14 by 77. Again, we could go ahead and rotate it. So I'm going to maybe set my rotation here to 90 degrees. We can set the span information. So maybe instead of at the top having a roller condition, we can make this a fixed condition or even a free condition. So make this a cantilever with a fixed condition at the bottom. We can change some of our bracing conditions again. Maybe again, just for out of plane, we'll brace at the supports. And then we can go ahead and add some loads. So very quickly, we can go ahead and add maybe a point load to the top here. Let's make it a dead load in the downward direction, and let's make it I don't know, 2.5 kips. And then we can go ahead and add a distributed load, so maybe a wind load here of 1/2 kip per foot along the entirety of that member. Again, our load combinations are being created for us based on the dead load and wind load categories that we've got applied. And then when we're ready, we can go ahead and toggle on the unity check. Now, when the unity check is ready, we're going to get our code check. So let's minimize the detailed report. So we've got our maximum code check and our governing load combination here. We could switch load combinations and view different load combinations if we want, but we'll just keep to the governing. We could also see our different diagrams again, maybe look this time at the axial diagram so we can see the axial as well as the reactions. And then if we look at the detailed report, again, all that same information, reaction information and calculations. In this case, maybe looking at the axial compression of this particular member. So seeing the axial compression here, seeing how that's all being calculated. And then if we want to use this or send this to a code official or another engineer, we could go ahead and click the download button to create for us a PDF that we can then view for later use. And so if I go ahead and open this PDF, we can see all this result information, all this output information ready for us and ready to share with other engineers. Thank you for watching this video on stainless steel member design in RISACalc. For more information about RISA and RISACalc, please visit risa.com.